Hey guys! So today you and I are going to talk about defects and finding them. So let's get into it. So the question in question was, Frederick, what is your recommended method for software developers to test their designs and find defects early in the process to ensure efficient development? Well, so what I usually do is that I follow a principle that it's uh, it's sort of I'm not sure. There probably is a more official term for it because I cannot imagine that I am the first person to think of this because I know for a fact that that's not true. I just don't know enough to tell you what the term is. So I'll try to describe it. So what I usually do is that I call it at the very least to design my abstraction from the inside instead of thinking from the outside. And basically, for say, the best way to describe it is when you're creating, say, an endpoint or something like that on your server, usually you have some idea for when, say, a user or a client or something that's going to connect and post or they're going to send data to you, right? And you sort of decide the format of what you want from the client. In other words, you're not trying to guess what the client is going to give you, anything like that. You're creating usually a DAO or DTO or something like that, a data transfer object, or just whatever term you prefer, right? An incoming request is going to come to you, and usually you have some idea of what data is going to be included. So you're trying to make a decision based on the needs of your server. And I try to apply that exact thinking to all the abstractions that I make. In other words, when I design a class, a function, or a visual component or something like that, I try to think as little as possible about the bigger context, if that makes sense, in the start of things. In other words, I'm not saying that I don't try to understand the whole feature, but I'm trying to not think about the state of the system at this point. The reason being because the problem when you start thinking in terms of, okay, this is just a function that lives in this gigantic call tree of different calls within my system, what happens is that you very quickly stop thinking about making this implementation a good implementation. Like in isolation, you're not thinking about your function or your abstraction. You're thinking about it as a part of a greater context. And what I usually find is that what very often happens is that people will try to start to tweak their abstraction so that it fits into the greater context, even if the greater context may be too big for you to fully understand, which is a problem because, as I say to people, if your idea of software development is that you have to understand the whole system as an entity before you start working, then you're screwed. Nobody's going to be able to do that because a lot of systems are so gigantic. And so what happens now is that the problem becomes that you're trying to think about too much at the same time. And it's very often that I find, especially I've done this 100 times, guys, this is why I do this, you miss things in the chain because there's so many things going on. Like your scope of thinking is too big, so it's easy for you to make oversights or not fully comprehend your context, and all of a sudden your abstraction doesn't actually fit into how the original software was designed, and now you have a problem because you're probably going to find out that your abstraction doesn't really work until much later in the process. And so the reason why this other approach works is because when I make such an assumption, when I start creating my abstraction, I know for a fact, which is there's actually a famous saying, which is the idea of make decisions late. Because the later you're postponing decisions to the latest point possible, because the longer you wait when you're doing an implementation, the more information you will have. The earlier you decide on an abstraction or a solution, the less informed you will be. So the idea being that what I want is to find a way for me to attempt a good solution early, and to create that solution that is, in my opinion, the thing that the system should be doing, a perfect abstraction. I create an interface basically for what I want the input that I need to execute my logic. And then when we're doing testing, for example, if I have an interface, then I can write a test and say, all right, let's see if I provide this data, these things are supposed to happen. I don't always write the test first, but the basic idea is the same. You create the interface for your abstraction first, and then you start working with your logic so that you can just focus on the thing that your abstraction is supposed to be doing. And then what happens is that when you then go to try to fit this abstraction into wherever, if you have an existing code base, we're assuming here that it's not a greenfield thing or something like that, right? What happens is that you might find that your interface either actually works really well, it fits nicely into the overall structure of how the code works, or you might find that it's not a perfect fit. But what you will do is that you will reduce the coupling between your abstraction and the rest of the code, which means that it's easier for you to change your interface, because if you realize, for example, that actually my interface doesn't work because my code is doing this and that, and I need to change these names or add those properties, and here are a few conditions where I have to think about this happening in more places, like maybe your abstraction is a shared function or shared class or something like that, and it has more than one use case. And then you need to tweak the interface, so change your abstraction so that it fits. It becomes a journey of discovery rather than you trying to read the whole code base and finding out. I hope that makes sense. You're going about it in the reverse. Instead of reading all the code to figure out what abstraction will work, you create the abstraction first based on your understanding, and then you try to fit it in and see, does that work? No, it doesn't work. Okay, why not? Because these things are happening as well. Okay, so let's tweak the implementation so that it works well for these situations as well. And then you try again, and then you make some progress, and that becomes a very iterative thing where you very quickly realize if your assumptions are right or they are wrong when you're trying to create whatever abstraction or system you're trying to do, right? That's why I am a big fan of doing proof of concepts, early stage things, like for people in front end, for example, I always tell them, don't create a solution where you create the UI and the network call at the same time. Always wait with fetching the data or like the server part as much as possible, because you can create basically, especially in the modern like SPA frameworks, you can create the entire user experience with just mocked data in memory or like static data, and then then present that to users and see, hey, was this the thing? Because I had this thing in my head. Is this the thing that you were looking for? This becomes the minimum investment for you, and then you figure out if this, like, it's trial and error, right? Without a lot of upfront cost. For the backend, it's the same thing. You create a class or an interface that you think is the thing you will need to as input to your logic, and then you try to implement that logic with just a fake set of data, or if you have other service calls or something like that, to see if this is going to work out. And then, as I said, you try to fit it into the greater context. And the best part, what makes me so happy about this, is that if you do this, you very quickly get free loose coupling, because you will very quickly find, like, when you go to fit that interface in, you might find that actually, you know what, this code, the surrounding code, is really shittily done. It's actually, this code is written in a way that doesn't really fit with the new set of requirements, but my abstraction does. So what do? Well, let's create a mapping layer, if at all possible, something that converts the bad code, quote unquote, or the data shape or input that you have, right, into a format that fits with this nice solution. And all of a sudden, you don't get into this shim programming where you're trying to retrofit your logic or this new set of requirements into a really, it's sort of, you figured out that the system is badly made, and instead of just continuing that process, you actually created, just by doing this, one single little nugget of nice code that fits the new use case in a fairly ugly system. And that is the process that will lead you to more and more improvements. At least that's what I argue. So what I want you to take away from this is that the way that I recommend to people for figuring out deficiencies or things within like the whatever abstraction or architecture you're going for, is to do basic proof of concept. Try to design your interface up front, or do you create your abstraction from the inside out. And the reason why I think that is so powerful is because that means that you're always only making the most minimal investment and then trying out your assumptions about the system that you're trying to work with, right? Before you try to understand the whole system, or you're trying to fit it into this gigantic blob of how everything works. You should, of course, understand a little bit. It's not like I don't read code that as part of the thing I'm trying to do. But what I'm saying is that it's very difficult in many times to foresee exactly how everything's going to work when you're trying to deal with the whole system as a whole. So I have always found that by just creating the interface based on my understanding of what I'm supposed to be doing, and then trying out if that interface or that abstraction fits into the context that I'm working with, and then sort of reflecting of this, was this a good interface? What assumptions did I make that weren't correct, and so forth. I iteratively evolve my solution. I make a small mistake maybe, and I realize that I missed an input or some variable or some class or something like that, and then I add that as well, and okay, now I see that that fits well and that does what I'm expecting it to do, and then you continue until you've covered all the use cases, and all of a sudden you end up with this kind of nice and clean interface that fits for all the situations. And yeah, that's the way I do it, at the very least, and I've always found it to work really well. Have a great day.